Suppose you are indifferent how to proceed with factoring. There is a general factoring strategy. If you follow, you will factor any polynomial. Okay? If it is factorable. What is the general factoring strategy? The first thing to do is that factor out the greatest common factor of all terms. Factor out the greatest common factor of all terms. The second thing, try to factor a binomial. That is, try to factor a binomial. We know that how to factor binomials, whether the difference of two squares or the sum of difference of two cubes. There are many ways. You know, we studied before. The third thing to know is to try to factor a trinomial. So, try to factor a trinomial. The first thing, of course, we know, factor the greatest common factor, try to factor a binomial, then try to factor a trinomial. Trying to factor a trinomial, maybe we have perfect square trinomial, using the trial method, whatever method you like, okay? The fourth thing to do is to factor a polynomial with more than 3 terms by grouping. That is, try to factor using grouping. The last thing to do is that to examine if the new factors can be factored or not. That is, examine new factors whether can be factored or not. Let's see examples. But before going to the example, let us review. We first factor the greatest common factor of all terms. The second step is to try to factor a binomial. The third step is to try to factor a trinomial. The fourth thing to do is to try to factor using grouping. The fifth thing to do is to examine if new factors can be factored more or not, okay? So let's go to examples. The first example, 2vx to the power 6 plus 14v cubed minus 16v. So going back to the strategy, can we factor the greatest common factor? Yes, the greatest common factor here is 2v. If you factor, you will have x to the power 6 plus 7x cubed minus 8. Now try to factor a binomial. Do we have a binomial? No. Try to factor a trinomial. Yes, we have a trinomial. What is the trinomial? This is the trinomial. How to factor it? Of course, you know whether you will use a perfect square trinomial or using a trial method. If it is a perfect square trinomial, let's check. Here we have 2v. This is it can be factored like this, so it is a perfect square trinomial. What are the two numbers? If you multiply, you will get minus 8, and if you add, you will get plus 7. Easy. Plus 8 and minus 1. So we will have here x. Here we have x to the power 6 and x to the power cube. So we said before it is quadratic in form. If you substitute x cube with u, you can see this can be written u square plus 7u minus 8, and if you factor it, you will get u here minus 1, u here plus 8. Okay, substituting with u with x cube, then here we will have x cube and here we will have x cube. Okay, now we have done the factoring of trinomial. Let's check if any factorization more can be done. Yes, this is a difference of two perfect cubes, and here also the sum of two perfect cubes. We know how to do that. We have a cube minus b cube. You know how to factor this, and you know also or expand it. If you know also a cube plus b cube, how to do that. So what are we going to do in this case? So this is equal to 2v. Here we can say x minus 1 multiplied in what? X square plus x plus 1, right? Also this one can be factorized in x plus 2. Here we put x square minus 2x plus 4. Now you should be done with your factorization. But before that, ask yourself whether this can be factored more or not. Check and see if it can be factored more or not. If it is not, you should know that you are done. Another question. We have 18x square minus 2. So using the strategy, the general factoring strategy, see if this can be factored using the greatest common factor. Yes, we can say if we take the greatest common factor as 2, this would be left as 9x square minus 1. Okay, now see if you can factor a binomial. This is a binomial. Can you factor this? We know this is written in the form of 3x square minus 1 square. So it is the difference of two squares. So 2 multiplied in 3x minus 1 multiplied in 3x plus 1. Check if you can factor more or not. No, we cannot factor more. So you are done up to this here. Let's take another question. We have 4bx cubed plus 32b. Okay, can we factor the greatest common factor here? What is the greatest common factor? We know we have 4b here and 32b here. So if we take 4b outside as the greatest common factor, we would be left by x cubed plus divided by 4. This is 8. So we have now x cubed plus 2 cube. So can we factor this or expand it more? Yes, we can do. Here we have 4b. Here we would be left with x plus 2 multiplied in x square minus 2x plus 4. Then you are done for factoring this one because you cannot factor it more. Another question. 16x to the power 4 minus 1. Can we take the greatest common factor? No, we don't have the greatest common factor. Can we factor it using a binomial method? We know this. This is 4x squared all square, and this is 1 all square, right? So we will factor it using this method, the difference of two perfect squares of a binomial. So this is equal to 4x square all square minus 1 square. This is equal to the sum multiplied into the difference. The sum is 4x square plus 1 multiplied into the difference 4x square minus 1. Okay, can we do something here? No, we cannot do anything, but we can do factor more here if we examine using the strategy. So this will be left as it is. However, this can be factored. This is like 2x all square minus 1 square. So it is the sum multiplied into the difference, 2x plus 1 multiplied into the difference, 2x minus 1. Now, can you factor this more? No. Therefore, when we examine the case, we cannot factor it more. So we are done of factoring this binomial. Okay, another question. We have now 81y to the power 4 minus 16. This binomial can be written as 3y squared, or you can say, in other words, 9y squared all squared minus 4 squared, right? So because we don't have the greatest common factor, so we jump immediately to the factoring of a binomial. Okay, so when factoring the binomial, this is the difference of two perfect squares, therefore it is the sum multiplied into the difference. Then it should be 9y squared plus 4 multiplied into the difference, 9y squared minus 4. So this cannot be factored more. However, this we can factor it more. This is equivalent to 3y all square minus 2 all square. So our answer should be here, this will be left the same, multiplied in the sum multiplied into the difference. Okay, 3y plus 2 multiplied to 3y minus 2. Now, can we factor this more when we examine? No. So your factorization is done at this stage, and you are already factored this binomial. Another question. We have 12ax squared minus 23axy plus 10ay squared. So try to factor the greatest common factor. See, what is the greatest common factor of all terms? Okay, of all terms. Is there a greatest common factor of all terms? No. We have here 12 for numbers. No. Here 12, here 23, here 10. Okay, what about variables? Let's check variables. We have here a, we have here x, we have here a, we have here x, we have here a. So the greatest common factor, if you factor it, this is only a. Okay, so this will be 12x squared minus 23xy plus 10y squared. Okay, now do we have a trinomial as a perfect square trinomial? Is this a perfect square trinomial? That is, this is squared and this is squared, and if you multiply them together, okay, with 2, will get the middle term. If not, try to factor it. Let's see right now how to factor this trinomial. Okay, of course a here will be left. Let's open parentheses and see. Now we have here 12x and we have here x. This is the trial method. The trial method with factoring. What are the two numbers if you multiply together? You will get 10y squared. 12x and 2y. This is 24y xy. Okay, what about this? Here we have minus 5xy. It is not the middle term. So let's check, try until you reach the final solution. Is, I will let you try until you get the final solution. Okay, the final solution for this factorization of this trinomial by trial method is minus 5y minus 2y. If you multiply, you will get plus 10y squared. If you add, let's see, 3x into minus 5y is minus 15y xy. Okay, and this is minus 8xy. If you add them together, you will get minus 23xy. Then your factorization is correct. So proceed with this factorization. Now see if we can factor this more. No. Then you, after examining and seeing that we cannot factor it more, your factorization is correct. Another question. We have 6ax squared minus 19axy minus 20ay squared. So let's, if we can get the greatest common factor out of this. The greatest common factor, you can see here a, okay, take a outside. We can see x, and no x is there, so we will leave it. Okay, what here if we put a or b, so 6 cannot divide 19, cannot divide 20, so we have only what, a as the greatest common factor, so we will be left by 6x squared minus 19xy minus 20y squared. Can we factor this trinomial? We may see that using the trial method, the factorization of this trinomial would be, it would be 6x plus 5y multiplied in x minus 4y. Now check, plus 5y multiplied in minus 4y is minus 20y squared. Okay, check if these two, if you multiply, we will have minus 24xy, and if you multiply this, we would have 5xy. Add them together, minus 24xy plus 5xy, we will get minus 19xy. Then your factorization is correct. Now check, can you factor this more? No. Then your factorization of this polynomial is this, and you are done. Another question. We have 3bx cubed minus 4bx square minus 3bx minus 4b. So how to factor this? First, let's check if we can factor the greatest common factor. Okay, we have here 3, 46, 3, 4, so the numbers cannot be factored. Okay, we have here b, 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 b. Okay, we will take b. Here we have x, but we don't have x in the last term, so we have only what, b as the greatest common factor. Okay, so take b outside, then this would be 3x cubed plus 4x squared minus 3x minus 4. Now what to do? It is not a binomial, it is not a trinomial, so we may think of grouping. Okay, so b here is outside, multiplied in open parentheses, then when you group, open parentheses. Okay, so we may take these two together, 3x cubed plus 4x squared together, and minus, take now 3x plus 4. Okay, oh, close parentheses. Now you will have b, open parentheses. If you take the greatest common factor out of this, you would have x squared, right? So put x squared here, then we will be left by 3x plus 4. Okay, now take the greatest common factor out of this, we don't have, so it is left as 3x plus 4. Okay, take the greatest common factor out of this expression, which is of course 3x plus 4 and 3x plus 4 here, so we will be left by b here. Okay, x squared, before that take 3x plus 4 outside, then we will be left by x squared minus 1. Oh, this is expanding. Okay, x squared minus 1, close, because if you divide 3x plus 4 by this, you will get minus 1. Okay, or in other words, which is correct, to be more correct, if you divide this by the greatest common factor, you will get minus 1. Okay, so let's continue our answering. Now we have something which expanded. Okay, Okay, are we done in this case? No. Why is that? Because this can be factored as well. So we will here be left with b multiplied in open parenthesis also 3x plus 4 will remain the same, multiplied. This is the difference of two perfect square. Okay, so it is the sum multiplied into the difference, x plus 1 multiplied in x minus 1. Okay, now close the parentheses. Of course, this you can now eliminate these two parentheses because b will be multiplied in here, so in put it here. Okay, so b 3x plus 4 multiplied in x plus 1 multiplied in x minus 1, and you cannot factor this more, then your factorization is done. Let's take another question. If we have 2x to the power 6 minus 2, now how to factor this? Can we take the greatest common factor, take 2 outside, we would have x to the power 6 minus 1. Okay, this can be written as x to the power 3 all to the power 2 minus 1 all to the power 2. So this is eventually will be x3 all to the power 2 minus 1 all to the power 2. Okay, this is the difference of two perfect squares. This means it is a multiplication of the sum multiplied into the difference, so it would be x cubed minus 1 multiplied in x cubed plus 1. Now, are we done? Not yet. This can be factored and this can be factored. So, let's complete our job here. Okay. So, this is equal to 2 will be here, and this can be written as x minus 1 multiplied in x squared plus x plus 1. And this can be written as x plus 1 multiplied in x squared minus x plus 1. Can you factor this more? No, because you are done. It cannot be factored more. So you are done for this question. Another question. If we have 72bx squared plus 24bxy plus 2by squared. So how to factor this? First, let's take the greatest common factor, c. Is there any common thing about 72, 24, 2? Yes, the greatest common factor of this number is 2. Now, let's check b. Here we have b, and here we have b, so b here. What about here? Here we have x squared, here x, we don't have x in the last term, we don't have y here, and we have y in the last two terms, so our greatest common factor is 2b. So open parentheses, this should be 36 x squared plus 12 xy plus y squared. So we have this trinomial. Now try to factor it using the trial method. After using the trial method, we know that 6x multiplied in 6x is 36x squared. So this is 1. Now if you check that 1 multiplied in 1 is 1, but we are not interested in 1, we are interested in 1y, or let's say here y and here y. Okay, here y and here we put y. Okay, y multiplied in y is y squared. Now check. Okay, let's check the outer, the first, sorry, and the last. The first, if you multiply 6x into y, you would have 6xy if you multiply here y into 6x, you would have also 6xy. Now add 6xy to 6xy, you will get 12xy. Then your factorization is correct. Now if we examine, or asking yourself, can we go more? Can we factor this more? You can write this as here to be multiplied in 6x plus y all square. Okay, this is as simple as that. Now you cannot go more. Okay, up to this you are fine, by the way, if you are here, because you expanded this one. So up to this you are correct, and here also you are correct. Let's take another question. If we say 64y cube minus 60y square z plus yz square, how to factor this? You can see that the greatest common factor among them is y. Now you would have 64y square minus 16yz plus z square. Now factor this trinomial, of course using the trial method. The answer would be, we would have here minus z and here minus z. If you multiply them, you will get positive z square. Okay, now let's check the first. 8y multiplied in minus z is minus 8yz, and let's check the inner. The inner is minus z multiplied in 8y is minus 8yz. So add these two together, you will get minus 16yz. Then your factorization for this trinomial is correct. Now ask your question, can we go more? In fact no, but we can write this as 8y minus z all square. Okay, and you are done. Another question. Let's take another example. If we say, for example, w minus 5 all cube plus 8. Now we have w minus 5 all to the power 3 plus 8. This is the sum of two cubes. This can be written as 2 to the power 3. So if you are going through the general factoring strategy, okay, of course you cannot factor the greatest common factor out of this. However, this is directly the sum of two cubes. So this can be written as w minus 5 all cube plus 2 all cube. This can be now written as, here we put w minus 5, okay, of course, plus 2, right? Multiply the first one squared, which is w minus 5 squared, plus the, or minus the first multiplied into the second. Okay, so we would say w minus 5 multiplied into 2 plus the second square, so plus 4. Now complete your work. W minus 5 plus 2 is w minus 3. Okay, multiply. This can be decomposed as w square minus 2 multiplied in w multiplied in 5 plus the second one squared, which is 25. Here this can be written as minus 2w plus 10, right? And plus 4 will go down. So complete. Now here we have w minus 3. Here we have w square alone. We will add like terms. This is minus 10 2w, right, with minus 2w is minus 12w. Here 25, here 10, here 4, so 25 plus 10 is 35, plus 4 is plus 39. And you are done for factoring this one, because this you cannot factor it more, okay? This you cannot factor it more. If you can factor it more, then you are not done. However, this cannot be factored more. Please check. Let's have now 5xy plus 20y minus 15x minus 16. How to factor that? Let's see as the general factoring strategy the greatest common factor among them. We can say 5, okay? Because if you take 5 outside, it is the greatest common out of them. So we would have here xy, we would have here plus 4y, here minus 3x, here we would have minus 12. Okay, now can we do something? Okay, it is not a binomial, it is not a trinomial, it can be, let's see if it can be grouped. Okay, let's see how can we group this. How can we group this? If we group these two together and these two together, let's see, here we have xy plus 4y, okay, here we have minus 3x plus 12. Okay, now take the greatest common factor out of this. We can say it is y, right? Then we will be left by x plus 4, right? Here, if we take the greatest common factor as 3, we would have x plus 4. Okay, now we have these two as the greatest common factor of this whole expression. Okay, take it aside, we would have here y, and we take this x plus 4 before y, so without mixing things up, take x plus 4 outside, then divide this by x plus 4, you would have y, okay, y, and divide this by x plus 4, you would have minus 3. Then this is can be written as 5 x plus 4 y minus 3. You cannot go and factor this more if you examine. Therefore, your factorization is done at this stage. Now let's take this example, x squared plus 6xy plus 9y squared minus 1. So can you find any greatest common factor? I don't see any greatest common factor. The only thing you can do right now is factor by grouping. So let's take this, so we can group, and take this and we group. See if we can do something. Here x plus 6xy grouped together plus 9y squared minus 1 grouped together. Now take the greatest common factor out of this. We can take as x, we would be left by x plus 6y, and here we would be left, if we, there is no greatest common factor out of this. So your methodology when selecting how to group is wrong. Let's check if you can group something else. Okay, what if we grouped let's say, just look at this expression. What can we do here is that let's take here x and minus 1 and these two together another way. Okay, so to do that we would do the following. Here we would have 6xy plus 9y square, and here we would have x squared minus 1. Okay, then this, if you factor this, take 3 outside and y, you would have 2x plus 3y. Okay, here you would have also this methodology will not work, so let's check if there is another thing we can do. So be careful, there is nothing about grouping, however we have here a trinomial, right? So can this trinomial be factored? Let's see. Open parentheses, and this minus 1 will be left. Okay, put here x and here x. Now find these two numbers. If you multiply, you will get plus 9y square, and if you add, you will get 6xy. Let's see if we have plus 3y, and here we have also plus 3y. Now check the first, we would have 3xy, and check the inner, we would have 3xy. Add them together, they will form 6xy, which is the middle term. Then your factoring is correct for this. Okay, now ask yourself, is there anything can we do more or factor more? The answer to this question is no. Up to here, no. However, check if you can do to these two things. These two things is written as x plus 3y squared, and we have here minus 1, so it is the difference of two perfect squares, right? It can be written as x plus 3y all square minus 1 square. So now we can do something. It is the sum multiplied into the difference, x plus 3y plus 1 multiplied into the difference, which is x plus 3y minus 1, and you are done. Now you are done, you cannot do anything. However, be careful if you are in this step. See if the multiplication of these two can be conducted or not. We saw it can be conducted, and we left with x plus 3y all to the power square. Okay, so be careful not to stop. If you find any gap, go and factor. Another question. Now we have 4y squared minus 4yz plus z squared minus 9. What can we do? We see this trinomial. Okay, this, if you can focus, can be written as 2y all square minus 2 multiplied in 2y multiplied in z plus z square, right? This is exactly written as 2y minus z all square. Okay, so, or you can use factoring the trinomial immediately by putting here 2y and here 2y. Okay, and check. Okay, this is another method. So this is when we factor it is 2y minus z all square minus 9. Now this is the difference of two perfect squares. We have this as 3 to the power 2, right? So completing our factoring, this is equal to the sum plus 3, of course, multiplied into the difference 2y minus z minus 3. Now you are done. Another question. Now let's have this question, 8x squared plus 3x minus 4. If you try to factor this, you put here 8x and here 8 and here x and check. Also you may put 2x 4x and check. you will eventually, because I tried this question, you cannot factor it. However, a smart way to check if it can be factored or not, using the factorization theorem. If you remember, we would like to check if b square minus 4ac is a perfect square or not. Do you remember it? Okay, let's see. What is b? B is 3 square minus 4 multiplied in a is 8, multiplied in c, which is 4. Okay, so this is, or minus 4, c is minus 4. Okay, so this is equal to, here we say 9 plus 4 16 multiplied in 8 is 128. If you add them together, this is equal to 137. Okay, so 137 is not a perfect square, is not a perfect square. This means that not this trinomial, okay, not factorable or infactorable over integers, over integers. Another question: if you have this type of question, we know that the difference of two perfect squares can be factored. However, the sum of two perfect squares remains the same. So we put a full stop because we are not expanding this. Okay, we know the difference between different cubes is factored. Also, the sum of different cubes is factored as well. However, we have a restriction. When a square plus b square, it is not factored. It is not factored. Only this and this and this. However, a question such as this one, what are you going to do? I will never factor this because I have here a plus sign. So, but let's try to manipulate. Okay, let's see what can we do. You just play with math. Okay, math is a tool you play with. This can be written as 4x all to the power 2, and this, if you put here plus, this also plus 9 all to the power 2. Okay, so you cannot do anything on this. You cannot do anything. As you remember, we have a square minus b square can be factored. A square plus b square cannot be factored more. A square here, a cube plus b cube, there is a factorization. A cube minus b cube, also there is a factorization. So if you see plus and two perfect squares like this, two perfect squares, between them plus, you do not factor it. However, if a binomial, let's say x plus y square, this can be factored. Okay, however, x square plus y square cannot be factored. Okay, you have to understand that. Another question: if you have such a question, 5x multiplied with 2x minus 5 square minus 2x minus 5 cube. So now, as the general factoring strategy, I would take the greatest common factor. Let's take 2x minus 5 square. Now open parentheses, we have left here 4x minus, open parentheses, 2x minus 5. Okay, okay, see what is left now. This can be factored. This would be 4x square minus 20x plus 25. Okay, multiplied in 5x minus 2x plus 5, right? So this is equal to 4x squared minus 20x plus 25 multiplied in 3x plus 5, and you are done in this factoring because you cannot proceed more. Okay, or you can write it as before if you would like, because we are expanding, not factoring. Okay, so better to keep it like this. Okay, so it should be 2x minus 5 square multiplied 3x plus 5. This is more correct, this is more correct. Okay, so do not expand, keep them in the form uh, of this type. If it is squared like this, just keep it as it is. Okay, and you are done. Okay, if it is squared like this one, just keep it as it is. Another question: if you have 6x multiplied 3x plus 1 cube minus 3x plus 1 to the power 4. Now take the greatest common factor, which is 3x plus 1 all cube. Open parentheses, we will be left by 6x minus minus open parentheses 3x plus 1. Okay, now close. This is to the power 3. This is to the power 3. So what are we going to do with it? We will leave it as it is, 3x plus 1 to the power 3. Okay, multiplied in 6x minus 3x minus 1. Okay, so this is equal to 3x plus 1 all to the power 3. We would have here 3x minus 1. Okay, and that's it. Another question: if we have 4x squared plus 2x minus y squared, so what are we going to do with this? So let's check if we can do something. I would factor this, I would group these two together. Okay, let's check if we can do something. If we group them together, we have 4x, of course here, 4x squared minus y squared, these two together, plus 2x minus y. Okay, so what is this equal to? This is equal to, here we have 2x to the power 2, and here we have minus y to the power 2, right? Here will be left the same. Okay, so this is the difference of two perfect squares, so it should be the sum multiplied into the difference, right? 2x plus y multiplied with 2x minus y. Okay, here we have 2x minus y. Now take the greatest common factor, 2x minus y, open parentheses, we would have 2x plus y, and this will be left at plus 1. You are done for factoring this. Another question: a squared plus a minus b squared. How to factor this? What will I do is that by taking these two together and these two together, so a squared minus b squared together. Okay, minus is outside, or let's say plus a minus b. Okay, now we have the difference of two perfect squares, so it should be the sum multiplied into the difference, plus here this will go down, a minus b. So this is the greatest common factor, take it outside, here a minus b, we would be left, open parentheses, we would be left by a plus b, a minus b divided by a minus b is 1 plus 1. You are done for factoring this question. Another question: suppose I have a question says find all positive values of k such that the trinomial is a perfect square trinomial. This is the trinomial, x squared plus k multiplied in x plus 16. So we would like to find what is k. Okay, such that This trinomial is a perfect square trinomial. How to figure this out? We know that the perfect square trinomial is that we have here the first term and the last term, right? We have here x plus 4 square, right? This is equal to x square plus 2 multiplied in the first and in the second, so 8x plus the second what? Square. So k is 8. K is equal to 8. Okay. Another question, if it says the same, find k. Let's say 36x square plus kxy plus 100y square. When this is a perfect square trinomial, it should be that, okay, this 36, which is 6x plus 10y. This is, since it is a perfect square trinomial, this is 6x all square, and this is 10y all square. Okay, so 6x plus 10y square equals what? 36x square plus 2 multiplied into the first into the second. 2 multiplied in 6 is 12, multiplied in 10 is 120 x y, right? Okay, plus 100 y square. So what is the value of k? K multiplied in xy here and 120 multiplied in xy here, so k equals 120. This is the type of examples you are going to sometimes see as a trick how to solve that. You may take different also examples. Let's say x squared plus 16x plus k. Okay, this is a different approach. So find all positive values of k such that this trinomial is a perfect square trinomial. We can say what it is. If it is a perfect square trinomial, this means that 2 multiplied into the first, which is x, okay, multiplied into the second, okay, equals to 16. Okay, the second is what? Is it k? No, it is not k. K here is something squared, okay, or to the power 2. K here is, let's say, y to the power 2. Okay, let's put it y to the power 2. Okay, this means if this is x, of course, x squared, then 2 multiplied again, let me do it again for you to understand it. Okay, if it says this trinomial is a perfect square trinomial, this means this is squared, can be squared, and this is a squared number, a perfect square. So if this is x squared, it is square to the power of x to the power to the 2, and let's say this can be written as y to the power 2. Okay, then x plus y all to the power 2 is equal to x squared plus 2 multiplied into the first multiplied into the second. This means 2x y plus y squared, right? So now we can say that this can be written as x squared plus 2y x plus y squared. So 2y here is 16. Okay, 2y equals 16. Now divide both by 2, both sides by 2, you will get y equals 8. Okay, so what is k? K is y squared, right? k is y squared. So this gives us that k equals y squared, which is equal to 64. Focus on this, you may understand it better. Read it again and again and you will understand. I will give you another example. If I say find k that makes this trinomial a perfect squared trinomial. Okay, this is x to the power 2 and this is k multiplied in something, okay, ky squared. You see, ky squared. So this may be, focus please on it. Okay, a perfect square means that, let's say it is the ky square is a multiplication of zy. Okay, zy square. Zy square, if you square it you will get ky square. Okay, so let's take zy. Okay, and we have here x square. Okay, so what are we going to do right now? This is will be equivalent to x plus zy all square. Okay, not plus because we have here minus, so we would put here minus zy, a perfect square. Of course, this is x square minus 2 multiplied into the first into the second. This means minus 2 z x y plus the final term, what? Final term square, which is z y or z square y square. Okay, z square y square. Okay, now complete. You have here minus 2z and here minus 14. Minus 2z multiplied on xy and minus 14 multiplied on xy. This implies that minus 14 is equal to minus 2z. Now divide both sides by minus 2. This implies that this is 7. This equals to z. Okay, now we got z, but we don't know what is k. You see here ky square and here z square y. This means that z square is equal to k. Now take z, since z is 7, so square it. It should be 49 equals to k. Okay, then k we got it as 49. Okay, substitute here 49. You will get a perfect square trinomial. You will, if you substitute in 49 here, you will get exactly x square minus 14xy plus 49y square. This is exactly x minus 7y square. So it is a perfect square. This is for you to make sure. Okay, your answer up to here, you are done.